Okay, so all the class materials, mainly including the slides and some homeworks and some announcement emails, all of them will be posted in this website. Okay. Okay, and the goal of this course is to study deep learning in detail. Okay, and as announced in the syllabus, this course will be run in the form of a flipped class. Okay, so basically every class, this is your kind of homework or self-study by watching one of the most famous deep learning video lecture called the Stanford CS231N, which is focusing on the computer vision. But throughout our class this semester, I will also cover some other applications and techniques used in other than computer vision. And then this is the course website that contains the video lectures and also class slides. And during our class, where we meet like this every Monday and Wednesday, I'll basically take questions from you guys through some online Q&A board where you can just freely post your questions regarding what you studied from these video lectures. And that website is slido.com. See. Okay, so this is the website that I'm talking about, the slido.com, and you can even you can ask the questions even now, and then it will ask some access code, and then it will always be KUDL. I'm not sure if it's case sensitive or insensitive. Okay, it is not. Okay, so once you go to this website and entering this access code of KUDL, which is standing for Korea University Deep Learning. Okay, and then you will see this kind of board where you can just post any questions, or maybe you can just say hi here, and then it will be updated in real time. And then you can also vote some of these other questions, and then it will be always ranked in a decreasing order of this voting count. And so so the most voted one will be handled with the priority. Okay. And also, so back to this slide. And in the beginning of every class, we will have the 5-minute quiz. Okay. So it will be also done by entering some website. I'll just let you know about this website in the next class. But so once you go to some website. And then you put your name or student ID, and then just answer a few simple questions. Okay, and then that will be that will be reflected into your final grades, of course. Okay, and then so these are the homework until the next class. Okay, until this this Wednesday. Okay. So each class is about 1 hour or maybe 70 minutes long. Okay, so and also for your information, this CS231N this course is for graduate level course taught in Stanford. Okay, so it's already quite a demanding course because you guys are mostly undergrad students. So. And also at the same time, you guys will learn additional or some particular topics in more detail among what we studied from this online lectures. Okay, or I will cover some additional topics as well. So basically this course will be quite demanding course. Okay, so I heard that some students who took this exact same course about a year ago, 2 semesters before, some students said that this course is like a 9 credit hour course. Okay, because you have to teach like graduate level courses by watching these video lectures, and then you guys also have to understand what I explain during our class. Of course, this class, our session will be mainly utilized to handle or address your questions that you had by watching these videos. Any questions so far? Okay. And then this is an optional textbook. And these are some of the prerequisite background knowledge or courses that I assume that you guys are familiar with. So you guys have to be familiar with Python programming. Okay, so most of the deep learning programmings are done in Python, and also we will also utilize some kind of particular deep learning libraries on which is used on top of the Python language. Okay, so you have to be familiar with the Python and also NumPy libraries, and also maybe scikit-learn as well, which is a machine learning libraries provided in this Python language. And also we will mainly utilize deep learning libraries called the PyTorch. Okay, so there are two major deep learning libraries called the TensorFlow from Google, and also PyTorch. Okay, so I think this one is much easier than TensorFlow, especially when dealing with the sequence data, involving RNNs or recurrent neural networks or long short-term memory. So we will mainly use this deep learning libraries, and of course, again, this library is written in Python. So you will just import this library in Python, and then you will use this API or functions provided by these libraries. Okay, and then also this course is utilize quite a lot of backgrounds in linear algebra, and also some of the calculus, mainly using a chain rule and the derivative and so on, and then probability and statistics, and also most importantly, I assume most of you guys have some decent background on the machine learning. Okay, like supervised learning, unsupervised learning, and regression classification, and maybe regularization, overfitting, underfitting, and bias, variance, and ensemble modeling, and so on. Okay, so this course, in terms of our class hierarchy provided in this computer science department, so this deep learning is kind of on top of other prior courses, including artificial intelligence and machine learning. Okay, so I assume you guys have some good amount of background on this machine learning. Okay. So let me do some quick polls. So can you raise the hand if you took the artificial intelligence course offered in this? Okay, great. About 70%. And machine learning? Good. Data science? Okay. Who has already some background on deep learning? Okay. Okay, who currently do some projects or some research on deep learning? Okay. Don't be shy. Okay. Good. So these are some of the list of explicit topics that I assume that you guys have some backgrounds on. Let's see. And these are some course schedule. And here's the grading policy. So we will have maybe 3 or 4 times of one homework involving some programmings, and also just handwriting kind of exercise problems where you have to derive some equations and so on. And then we will have exam on midterm and final. And this one also includes the term project. And as I mentioned, we will have a in-class quiz and class participation. So you can just post your questions online, as I mentioned, in the slido.com, or you can just freely raise your hand at any time and then ask any questions. Okay, and then those class participations are based on your kind of active participation, such as asking as many questions as possible and so on. And don't underestimate this aspect. Okay, so I often see that many of the students are around the borders of your final credits. Among the A plus A and B plus B and so on, and then depending on these participation or how much I remember each students, I actually raise some of the students to a higher grade and lower some of the students' grade into a lesser grade. Okay, and then although I'm not gonna check frequently, but these attendance will be checked sometimes. And then if you miss one class, and then among the 100 points in total, you will get 0.5% deduction on your total points. Any questions so far? No.
Here we will have quiz every class, right? Like
Yeah.
That's kind of like
It's not guaranteed that we will have a quiz every class, but mostly.
Yeah, but that's I guess it's so many quizzes with only 5%. I mean, like grading.
Yes.
Okay.
It will be mostly quite simple ones. Although, it will be simple if you studied properly the video lectures. But most of these questions will, each quiz will be composed of maybe around three questions, and they will be just a simple kind of a multiple choice type of questions, or some kind of questions of filling the gaps.
This is not a very related question, but do you also teach this class in first semester, spring?
I don't think so at this point. It will be offered annually, I think. Although I'm not sure. I mean, if some other professors may want to open this same class in the other semester, but in my case, I don't think I can open this same course in the next semester. Okay. Any other questions? And 네. 그 저기 질문 한글로 해도 돼요? 네. 3개씩 들으면 참 좋을 것 같은데 그러지는 않고요. 네. 일주일에 1.5개 정도라고 생각하면 돼요. 지금 첫 주라서 이 사실 좀 처음 3개 정도 렉처는 이게 사실 딥러닝의 좀 전초전이거든요. 그래서 사실 나 스스로도 여기를 좀 많이 다루지는 좀 않으려고 해서 최대한 좀 빨리 보려고 하는데, 일단은 뭐 또 학기 초가 그래도 시간이 좀 많이 남을 테니까 그래도 좀 그때 좀 전화가 많이 원래 안 오는데 하여튼 한 1.5개 정도라고 생각합니다. Okay, so on average, I mean per week, you will have to watch maybe 1.5 classes. I mean video lectures, which is about maybe close to 2 hour worth, I think. Yeah, because one video lecture will be around 1 hour and 15 minutes or so. Any other questions? Okay, then so again, you have to watch these courses, I mean video lectures, and then be prepared. You have to be prepared for the quiz, okay? And also the quiz will be done in the beginning of the class. So if you are late, then you have no chance to take the quiz. Okay. So deep learning. So this is a little bit less academical terms. So in many of these academic kind of papers, I mean, research papers don't use this term, okay, deep learning. So when I first submitted deep learning related papers on my own, I put this in the title, and then it got rejected. And I suspect that was the one of the main reasons why my papers were rejected. But anyways, so it's a kind of a buzzword, or kind of a less academic or kind of casual terms. And then instead of it, we often use deep neural networks. Okay, deep neural networks. So it's basically stems from or rooted from this artificial neural networks, which was invented maybe several decades ago. Okay, and then let's see, deep learning or deep neural networks looks like this. Okay, and then it has the this kind of input layer, and then some of the output layer. Okay, and then in the middle we have some hidden layers. Okay, so in this particular case we have one hidden layer, but in the second example we have two hidden layers. And then if we stack more and more layers, maybe up to several tens or several hundreds or even thousands. Okay, and then we stacked a lot of layers. So that is called the deep neural networks, because we kind of stacked these layers quite deeply. Okay, and then what is this input and output? So let's just look at some of these examples. So if you want to classify a given handwritten image, which is given in the form of this bitmap. Okay, so it is just a handwritten image of digit 1, okay, and then to computer, or as a kind of digital forms. So it will have some resolution, or basically the size of this image. And then suppose this image size is 28 by 28, and then at each pixel it will have some value ranging from 0 to 1. I mean, it's just a normalized value. And usually if we handle the color images, and then we have 3 channels of red, green, and blue, right? And then it's like 3-dimensional cube, right? So 28 by 28, and then we have 3 channels of maybe red, green, and blue, and each of these values will be typically ranging from 0 to 55, right? Okay, so these are the numerical form, or kind of a numbered form of this given input image. And then if it is a grayscale, and then we can just utilize the average number of this RGB, like 3 channels numbers, and then it will still have the range of 0 to 255, and then we can normalize it into 0 to 1, and then we will obtain this, right? And so if it is a black, and then it will have larger values at the corresponding position. Okay, and this is the input, and then it has again the resolution or the size of 28 by 28, right? And then it should be given to our neural net as an input, right? And so those node in a particular layer is corresponding to a particular scalar value contained in our image, right? And so here, this is a two-dimensional kind of form, right? Two-dimensional array as an input, but we can typically just chop them vertically or horizontally. And then let's say we chop them vertically, and then just to move these at the bottom of the first column, okay, and then this guy to the bottom, okay, and then we will have a long and thin vector or one-dimensional array by rearranging these two-dimensional arrays, right? And then in total we have 84 numbers, which is 28 by 28, right? And so that will form our input layer, okay? Okay, and then if we want to classify this guy into a particular digit among 0 to 9, okay, and then we can design our neural net so that we have 10 different output nodes where each of them is corresponding to one particular digit value, okay, and then through some functions done in these layers, including these hidden layers, okay, and then given a particular input vector, and then we will obtain a particular output vector, and then if we want to classify a given image into one of these 10 digits, and then we can just simply pick up the largest, the digit that has the largest values, okay. So that way, so input dimension or the number of nodes in the input layer is determined by our input data, okay. If our image was 28 by 28, and then it will determine the number of nodes in the input layer, right? And then the output layer, the number of an output layer, number of nodes in the output layer is determined by our task goal. So if we want to classify each handwritten digit image into one of the 10 digits, and that's why we have to have 10 different nodes, okay. And then if we want to classify this one as maybe the digit written by either men or women, okay, and then we have to classify one between the two, right? So in that case we will have two output nodes, okay, or if it is a binary classification, we can just simply have one single node, okay. But anyways, so input and output layers are determined that way by our task goal and the input data and numbers basically contained in our input data. But in the middle, how many layers we will have, and then how many nodes we will have within a particular layer is completely dependent on our design choice, okay. So if we want to have more complex complex neural networks, and then we can add more layers so that our function can do more complicated things, okay. Okay, then someone tested this word. Okay, so again, if you have any questions, during our class, and then feel free to just post your questions. So this website is quite insightful, and you can actually have fun by playing with these neural nets. Okay, so in this case, you can actually change your designs of your neural networks, and also you can also change your task goal as well, just like classifying the same input handwritten digit images into one of the 10 digits, or one of the genders of the person that wrote this image, okay. Okay, so in this case, it's a classification task. So here we have a choice of choosing, selecting either classification or regression. So both of them are kind of a supervised learning, right? Supervised learning. And the classification is predicting the discrete or integer or categorical variable, just like digit among 10 different digits. So in those digits, there is actually order, but in the case of men or women, there is no orders, right? So in that case, it is a categorical information, right? And in case of discrete variables as our target variable to predict, the example will be like, suppose you want to predict a person's blood pressure into low or medium or high level. Okay, so in this case, less than maybe 80, and 81 to maybe 120, and this one is 121. Okay, so in that case, so we want to classify a given person. Based on his or her feature information like height and weight, and maybe the location of his or her residence and so on. And then we want to classify one among them. And then these values are actually ordered one, right? So these are not called the categorical variable. So this is a discrete, but it's an integer kind of variable, because integer is a kind of discrete, and also they have particular orders, right? Anyways, and then regression is to predict the real values, right? And then, okay, so we set the classification, and then in the case of classification, we assume the two classes, and then these are the given training data, right? And then the x and y axis are the two features that we are given. So if we want to represent a person's feature vector in terms of his or her height and weight, and that will be x and y axis respectively. Okay, and their labels are represented by those colors. Okay, and then we have, of course, two input nodes, right? Because we are originally given the height and weight, right? But what about these? Okay, what about these? So we can turn on additional input nodes, right? But all these input nodes are kind of derived feature values from the original two of these original feature values, right? So one of them could be x, the first feature value squares, the second value squared, and the product of them, and then sine, and so on. Okay, but this one is a kind of more kind of standard situation. And then, yep. So in the middle, okay. So this is the output node where we have only one node, because we are doing the binary classification, and binary classification is represented a single scalar node. Okay. In the case of binary classification, what is the most basic method that we use? Can you tell me any kind of binary classification method? SVM or simpler one? Logistic regression, right? Logistic regression. So logistic regression is giving the scalar output, but that scalar output is actually computed from the sigmoid function, right? Sigmoid function that has the range of, from 0 to 1, right? And if that value is shown to be larger than 0.5, and then we classified it into positive class, or if it is less than 0.5, and then we classify it into negative class, right? So so this one is a scalar output node. Okay, one single node, which is kind of a really enlarged kind of version, and then these two are our hidden layers and the number of nodes within each layer. Okay. Okay, then, so in this case, I just completely removed discarded any hidden layers where we only have an input and output layers. Then in this case, so this one is the output while the training is being done. Okay, and then how we read, or the way we read this kind of output is, so those actual dots or points with the particular color is our training data. Okay, and then in the background, the colors are assigned gradually or smoothly, right? And those colors are the predicted value from our learned neural network. So in this case, consider maybe some point, maybe over here, and then it will be classified as what? Positive one, or this orange one, right? And if we are given the test point around here on the right bottom, and then it will be classified as the blue one, right? So, so in this case, suppose we are given the test point over here, and then the prediction value is blue one. But as we can see, the training data around it will all have the orange one, right? So those regions are clearly those misclassified regions, right? So again, how we read this graph is the actual points and their ground truth label that are given during the training time. Okay, these are actual points are the actual training data, and at the same time, the background color is representing at any given point our prediction results are shown as this color. Okay, so this one is clearly the wrong kind of case where we couldn't properly learn their classification boundary. And then is there anyone who maybe studied the Andrew Young's machine learning Coursera course? Not many? Okay. So in this particular case, because we didn't have any hidden layer, what is the actual model that we have in this case? So in this case, we have two input nodes, right? And then we have one output node, and then we have two input nodes, which is corresponding to height and weight. And then, those edges are representing some linear kind of combination of maybe AX1 and plus BX2 and plus C, right? And A, B, and C are those parameters that we want to learn, and these are the parameters being learned while this neural net is being played like this. Okay. Okay, and then after this, as I mentioned, this is a classification problem, and if we have no hidden layer, it's just equivalent to the logistic regression that performs this binary classification. And then what is the nonlinear function, or the the function that we go through after getting this linear combination of the input, that is called this sigmoid function, right? Sigmoid function, right? Let's see. How does the sigmoid function look like? So this is something like this, right? So it has a few different names like logistic function and maybe sigmoid function and so on. So this is the function that we use in the logistic regression, right? And so after getting AX1 plus BX2 plus C, okay, and then this one will be used as an input to the sigmoid function. So if it was 3, and then it will have this, and then the function output of this sigmoid function will have this value. Okay. Okay, and then if you studied well about this logistic regression, and maybe support vector machine or any other linear classifier, and then this one being equal to 0, that is our classification boundary or decision boundary, right? Decision boundary. And that is when we give the input as 0 to this sigmoid, and then sigmoid output is of 0.5, and then that means like 50% being the positive class, which means that 50% being the negative class, which is like a 50-50 situation, right? And so in this case, yeah, so it is like, yeah, suppose A1, A2, B and A, B, and C are 1, 2, and 3, and then it's like x1 plus 2, x2 plus 3 equals 0, and then let's just change it as x and y, and then we can just draw an x and y, and then y is something like this, right? So it's like this kind of decision boundary, right? Right? So if it is above this decision boundary, and then we classify it into positive and then negative if it is below that line, right? And then this decision boundary, if we didn't use any kind of internal hidden layers, and then yeah, this linear output is just passing through the sigmoid and then giving the final score of our prediction score, and thus our decision boundary is this straight line, right? So that straight line cannot maybe separate these nonlinear kind of decision boundaries, right? So if someone remembers how we simply handled this kind of problem by still using the linear classifiers, so that we can handle this nonlinear decision boundaries. And then we can actually use some feature augmentation or adding kind of additional features, yeah, computed by the original features. So for example, if we just add those two, which is just yeah, converted version of the input features. It's just simply height squared and weight squared. And then if we add those two as an additional features, and then now we will have 4 different inputs from the perspective of our model. And so it's like x1, x2, and then we have x3 and x4, right? And then actually this x3 is x1 squared and x4 is x2 squared. But yeah, it doesn't matter from the perspective of logistic regression. It just handles or takes the 4-dimensional inputs, and then it has the freedom of assigning different linear combination weights, right? But anyways, if we augment our features that way, and then I hope it gets trained. But yeah, in principle, it should be trained, but it doesn't seem so, right? Right? Okay, and then let's do some challenge. Okay, so initially it should have used a sigmoid. Okay, so that's yeah, when setting it as a sigmoid, and then it is equivalent to the logistic regression. Okay, so in that case, let's try once again. Okay, so it seems to be quite hard to just properly learn the decision boundary. Although we know it should be able to be learned, right? And why? Can we represent the decision boundaries like the circle in order to handle that previous case when using x1 squared and x2 squared? Okay, like ax1, bx2, cx3, and dx4 plus e. Okay, so this is kind of our decision boundary. Although, yeah, that will be passed into the logistic regression, and then depending on whether they are negative value or positive value. So this is the point where we have the probability more than a half or less than a half, right? So that way, this linear equation being 0 is our decision boundary, right? But anyways, now this x3 is actually x1 squared, and x4 is x2 squared, right? And then how do we kind of represent that decision boundary of a circle, right? It is simply 0, 0, and 1, 1, and then maybe minus 2, and then x1 squared and x2 squared, and then 2, right? So it successfully represents the decision boundary of a circle, right? It can even represent kind of an ellipse and so on, right? So we know it should be learned, but somehow it is not being trained, right? Okay, let's see. Yeah, let's just play with this neural nets by changing some of these activation, something called the activation function. I thought it should be trained. Let's see. Why is it not being trained?
I think maybe you want to reset it first.
Oh, really?
A little bit.
Ah, I see. How do you reset it?
Beside the pause button.
What's that?
Beside the pause button.
Pause
Beside the
button.
pause.
Ah, okay, yeah. Okay. Did I reset it? Okay. What will be the problem?
I think it's just a picture that doesn't change because it is converging.
Yeah, the loss is 0.
Yeah.
So it looks like it's properly learned the parameters assigned to x1 squared and x2 squared, and almost 0 on the original x1 and x2. But we don't know what the bias value is, or here the e value. I mean, we cannot check if that e value was properly trained or not, because it doesn't explicitly show that. Okay, it should work, but I don't know why it doesn't work. So it could be your first homework. Okay, playing it with it, and then succeed on properly training it. But anyways, let's just change the designs like this. Maybe I add more hidden layers, so on. I don't think I need it. Does it change at all, that figure on the right?
No.
No? Okay. Okay, it is now reset. Let's try again. I don't know. Yeah. Okay, so you already learned how difficult it is to train our neural nets. Okay. So I'll try also more. When I get back. But sometimes even for these simple settings, you can easily find that it is quite difficult to kind of train these models, and kind of the most difficult version is like this. Okay, so this one has really complex decision boundaries, and then because it is really complex, it should have many hidden layers. Okay, at least it seems to be much more dynamic than before. Okay, so yeah, so in this case, it is even more difficult, right? So this data set is called, this specific, this data set has a specific name called the Swiss roll data. Okay, so you know the Swiss roll cake, right? So the jam is having that kind of shapes, right? So it is called Swiss roll data, and then machine learning researchers have played with that data set for maybe at least several decades, I think. And so if you search for like, so it is really difficult to succeed in training that Swiss roll data and properly learning the decision boundaries. So so if you actually search for the playground, TensorFlow playground, Swiss roll, and then someone actually posted some of the proud results of their own that succeeded to properly learn these decision boundaries. So in this guy, his or her design, his or her own design was to use just a single hidden layer, and then maybe 2, 4, 6, 8 hidden layers, and instead, and also he also used a lot of feature augmentation, right? And then also maybe some other guys. Okay, so this one seems to be much dynamic. Oh, that's good. So in that case, this guy used maybe 3 hidden layers in the middle, and then these many number of nodes. Okay. Okay, then so in this particular case, let's think about additional kind of aspect. Okay, so in this case, what would be the training accuracy? What would be the training accuracy in this case? So again, I mentioned about how to read this kind of result, right? Training data with an actual point and their colors and their background as the predicted value, right? And at least given those blue points and the red points that are actually given, right? Those colors are matching the background color, which seems to be like all the data being classified correctly, right? So in this case, the training accuracy will be 100%, right? But what about the test accuracy? Do you guys expect it to have like maybe 100% accuracy or maybe close to 100% accuracy? So in this case, so these are the limited number of training data that we are given, right? And then suppose we are given another blue point around here. So from this kind of pattern, we have no problem in extending those lines more and more, right? And then we can imagine some of the test point which is not yet seen during the training phase as this point, which is still blue point, right? And in that case, it will be misclassified in our model, right? Okay, so so that is basically the gap between the training accuracy and the test accuracy, right? And minimizing the gap. I mean, in principle, if we use more and more complicated models that has more number of parameters, such as like adding more and more layers and number of nodes within the layers, and then in principle we can kind of represent really complicated decision boundaries given the training data, but we do not know. We do not actually care about the unseen regions like this. Okay, so in that case, how can we, yeah, so in that case, the training accuracy will be 100%, and then the unseen data and their test accuracy will be maybe around 80% or even maybe 70% or less, right? So there is a gap between the training accuracy and the test accuracy, right? And then reducing the gap. How can we reduce the gap? So the simplest way is to provide more and more training data, right? Okay, so we can fill out the training data entirely over these entire region, right? So in that case, our training data will cover every single regions in our feature space. So in that case, if we can achieve 100% training accuracy, and then it means we achieve 100% test accuracy, right? But if we, yeah, is there any other ways? I mean, how do we reduce the gap between the training and the test accuracy? So that is generally called the regularization, right? Regularization, like L1 or L2 regularization, and also in the case of deep learning, the dropout and the batch normalization, and any kind of a normal. Yeah, so there are many different normalization in these days, and those different normalizations used in the deep learning or deep neural networks are actually working as a regularization factor, which reduces the gap between the training and the test accuracy. Okay? And also, this kind of overfitting to our training data is actually working as a kind of blind side or pitfall that can be utilized by the malicious attackers of our neural nets. Okay, so if you this term adversarial is quite famous and widely used popular term in deep learning literature because it's related to generative adversarial networks, which actually produces a lot of interesting kind of generative examples. And then also in terms of security of our neural nets. So for example, if you just develop the deep learning or deep neural network, you trained really well your deep learning so that it can properly work as your kind of auto kind of navigator in your autonomous driving kind of systems. Okay, and then if you just manipulate, I mean, some hackers or attackers may just manipulate a little bit of your car's camera or the input pictures, and then you can easily fool your autonomous driving system so that it can crash into some person or some walls and so on. So that is called the adversarial attack, okay, like malicious attack, okay, and then so this adversarial examples are also quite on hot and active research areas. And then let's look at some examples. Okay, so this is one of the example posted in the original papers that proposes this adversarial example. And then so this is about the example where you learn or you trained your deep learning so that your model can classify the given image, I mean, into a particular object. So if it is a panda, and then it will classify it as a panda, and if it is maybe desk or chairs, and then it will classify into the corresponding classes. And in that case, so if you just manipulate this image, so that we just add that kind of just a random looking noise, like all red, blue, and green, and so on, in the corresponding pixel positions, and then this is the resulting image. Okay, so in this resulting image, your classifier will classify it as I forgot the meaning of this gibbon, or what is that? Does anyone know the meaning of it? No? Monkey? Oh, is it monkey? Okay. So in the case of monkey, it is kind of similar to panda. But there are a lot more extreme kind of results as well. Okay. But anyways, yeah, it will classify this still panda-looking images into like a monkey with really high confidence, with 90%, 99% confidence. Okay. So there are so many examples like this. Okay. Okay, so yeah, related to this example, okay? So you can think of this point as your original panda, okay? And then slightly moving this point towards the classification, decision boundary, towards that direction. And then by only moving this point with this amount, okay? And then you can safely just pass across this classification decision boundary, and then you can actually fool your classifier so that it can misclassify it into quite different classes. Okay. So yeah, intentionally moving or intentionally changing slightly your input feature vector representation. Okay, in a malicious with a malicious intent, and then that is actually utilized as a adversarial attack. Okay, and also similar to kind of literature in the security. Yeah, there are many papers that proposes a new attacking algorithm to fool the neural net, and also at the same time there are many papers that proposes kind of defending algorithms against those different attack algorithms. Okay, so it's like 창과 방패 싸움이 뭐죠? 영어로? 창. 네. 창과 방패 싸움 그런 거 있죠. Any questions so far? Okay, so 네, 이거 팀별. 네. Okay, so I forgot to mention about the details of term project. So yeah, I expect you to form up to maybe 3 persons, okay, for your term project. Although, yeah, it is no problem to do the term project on your own. Okay. Any other questions? Okay, in that case, I can. Oh, it's not an admin page. I can log in as an admin because I created this page, and then I can archive it or I can kind of remove it. Okay, if it is resolved. Okay, so back to the intro of deep learning. So you guys have kind of a rough idea about how the neural networks or the deep neural networks looks like. And also, deep learning is a particular category within the machine learning, and this machine learning is a category within the artificial intelligence, right? So what's the difference between the machine learning and the artificial intelligence? Or, yeah, what are the approaches corresponding to this star regions, which is artificial intelligence but not machine learning? So what's the difference?
Rule-based chess machines.
What's that?
Rule-based chess bots.
Yeah, right. So yeah, right. This star region is corresponding to the rule-based thing, right? So you just develop your own algorithm, right? Yeah. So without any kind of previous examples or training data, right? And then the machine learning is assuming that the model is just kind of it is learned. Yeah, it is just a general purpose learner or machine learning model, just like a linear regression where we have the coefficients that are not yet learned. And then if we give training data and then those parameters are adapted or adjusted so that it can fit your training data, right? So this guy requires or assumes training data, and this learning means learning from the training data. Okay, and then deep learning is also a kind of machine learning, but this is a particular machine learning kind of model of these neural networks or deep neural networks, rather than other machine learning models like linear regression, logistic regression, k-nearest neighbor classifier, support vector machines, and then maybe decision trees and gradient boosting or random forest, and all these non-neural network machine learning models exist, right? And then these algorithms are corresponding to this region. And then if you select the machine learning models as neural networks, then that will fall into this category. Okay, so the factors for recent success of deep learning, three main aspects actually play the main role of bringing big success in deep learning: big data and improved training algorithm, like this. And then you will learn about the gradient vanishing problems, just like the previous example where we had a hard time in training really even simple kind of ring type classification boundaries, right? So it was not properly trained, right, for some reason, right? So so that way, so we need additional advanced techniques so that we can properly train our model. And this regarding the issue of this big data thing, let's see if I have, maybe not. Okay, so there is a kind of well-known and widely used graph. So suppose this x-axis is number of training data. Okay, y-axis is your test data accuracy. Okay, and then if you use a linear regression or logistic regression or maybe decision trees and so on, and then it will be trained like this. Okay, so up to maybe 100 or 1,000 data points, and then it can quickly increase the test data accuracy up to maybe 80%. Okay, but in the case of deep learning, it has the patterns like this. Okay, so if you have a small number of data, and then you will actually be often frustrated by seeing that, okay, so you actually use the deep neural networks with the really complicated and advanced architectures, and then you compare the performance of it against the performance of maybe standard or traditional kind of machine learning models like maybe decision trees or random forest and so on. And in many applications, non-deep other models than the deep neural networks actually often performs much better than the deep neural networks. Okay, so that way, I had the exact same experiences, and then so I was not kind of I was kind of confused, and why I mean, is it really a good algorithm or a good model and so on? But the deep learning is really shining when you have really large number of data. Okay. So this is the about the hardware. So if you just train or use your deep neural networks on the CPU, and then even if you buy maybe several $1,000 worth CPUs, and then it can take around maybe a month or even a year to properly train a particular model using your big data. But if you happen to train your model using this GPU, which is only maybe $1,000 or less than $1,000, and then it can just be trained within a day or maybe within a few days and so on. Okay. This guy, is not doing much research in these days, but I often call him as Paris Hilton in the deep learning community. Anyways, yeah, and these are the major conferences in AI. If you want to like search for some interesting research papers for your own projects, and if you want to like study advanced deep neural network techniques, and these are the conferences that you want to look at. Okay. And then if you happen to have a publication or if you write a paper and then get accepted in one of these conferences, and then it may change your life. Okay.
Will there be GPUs available?
Oh, that's a good question. So we got assigned one single machine that has 4 GPUs. I don't think it will it will suit the needs of all these students. So one possible solution is to use a Colab. Okay. So you can search for this keyword of Colab. So it's really GPU cloud, graciously provided by Google for free. So you can use that, and also in some of these Amazon or Microsoft Cloud, if you just subscribe using like your student account, and then you may get some free credit for maybe several tens of hours or so. Anyways, I'll also see if there's any other better ways. Any other questions? Okay, then I want to just end with one of the interesting projects or interesting research papers that was published in maybe a couple days ago. Okay, so this is one of the deep learning and computer vision applications where you have the source video where on the top left, that guy is a really expert, dancing expert. Okay, and then he dances, and then suppose, okay, so this guy is dancing, and then this guy is just like you. I mean, who is not good at dancing, and then you can just impose a lot of these dynamic movements into that person, with this realistic kind of quality. Okay. It has also some music, but okay, so you can do that kind of interesting things by using deep neural networks, and that's it for today's class. And let's meet next this Wednesday. And again, please be prepared for your quiz. Okay, and don't get late. Thank you.
교수님, 제가 부전공 수업을 들어가지고 학생이 없어서 이 수업을 신청 못했는데 혹시 청강 괜찮아요?
네, 청강 괜찮아요.
수업에 참여 문제가 없을까요? 감사합니다.
네.
혹시
네, 괜찮아요.
시대에 따라 요청돼요.
그러면 네. 저기 강의 자료라든가 퀴즈 같은 거는 여러 가지 정보들은 나한테 이메일을 보내주면요. 내가 청강생으로 등록을 해주면 블랙보드 상에서 이메일을 학번이랑 이름을 하나 보내줘요. 네.
For the quiz
Next class.
there are like 3 lectures.
Right.
One of them is optional.
Right.
Does that mean like it's gonna be in the
So
quiz?
it will be not covered. So quiz will be not cover that first lecture because that is literally an optional.
Okay. Yeah. Thank you.
약간 피처 아그멘테이션에 대한 피처 아그멘테이션 X1, X2도 있고 그거를 또 제곱해서 새로운 피처를 추가할 수 있잖아요.
네.
그런 게 뭐 레지던스 레이어 쌓는 거랑 비슷하게 좀
레지넷이요?
레지던스에서 뭐 레이어를
네.
쌓는데 이제
아, 네.
아래 레이어가 윗 레이어가 아래 레이어를 포함하는
맞아요.
아이디어잖아요.
네.
그것도 피처도 비슷한 아이디어.
그렇게 비슷해요. 네, 비슷해요. 네. 이거는 그러니까 어떻게 보면은 이제 인풋 피처는 어떻게 보면 오리지널, 그러니까 인풋 레이어에서만 주어지고 그 다음에는 영영 그 오리지널 인풋을 볼 수가 없고 이거에 이제 트랜스폼드 된 버전만 볼 수가 있는 거잖아요. 그래서 이제 뉴럴넷이 이제 필요하다면 이 앞쪽에 있는 거를 직접적으로 이렇게 활용을 했으면 좋겠는데 못해서 그걸 부셔줬더니 아까와 같은 그런 피처 어그멘테이션 첫 번째 레이어에서 입력 피처를 어떤 형태로 변환을 해갖고 넣어주는 것과 거의 유사하게 그렇게 이제 동작을 하게 되고요. 그리고 또 중요한 거는 이제 레지넷이 기본적으로 그것 때문에 그런 이제 뒤쪽에서 어떤 피처 어그멘테이션 때문에 잘 하게 되는 거고요. 그 다음에 또 중요한 게 그 레지넷의 기본 그런 어떤 히스토리를 보면 이게 예전에는 뭐 한 10레이어, 뭐 한 20레이어로 뭐 적당히 뭐 VGG넷 혹은 구글넷까지 이렇게 쌓아서 이렇게 성능이 뭐 85까지 나왔다 예를 들면. 그럼 레이어를 막 더 신나서 막 더 쌓아봤더니 어느 순간부터는 이제 트레이닝 성능도 안 나오는 거예요. 트레이닝 성능이 한 90 나오고 테스트가 85가 나왔는데 레이어를 더 붙였더니 트레이닝 성능도 이렇게 같이 떨어지더라. 그러니까 문제가 뭘까 이제 좀 생각해봤더니 그런 지금 이야기했던 것처럼 그러니까 뭔가 필요하다면 입력이 그대로 좀 전파가 되면 좋겠는데 그러니까 필요하다면 그러니까 아이덴티티 펑션으로서 역할을 좀 해주기도 어렵다. 그러니까 레이어를 붙이면
레이어를 너무 많이 붙이면
레이어를 붙이면 하나를 더 붙였을 때 만약에 이게 아무것도 뭔가 역할을 할 필요가 없다. 그럼 얘는 그냥 아이덴티티 매핑으로만 역할을 해주면 되잖아요. 근데 그거를 실제로 못 해주더라 이거예요. 그래서 레지넷이 좀 뭐 그런 식으로 좀 발전이 있어요. 그래서 필요하다면 이제 여기서 이제 아무것도 안 해도 뭔가 이제 뭐 아이덴티티고 하여튼 그 변형이 가해지지 않은 그거를 하는 게 중요하더라.
저희 펌프 저번 학기 하시는 것처럼 자유주행.
아, 네, 자유주의.
혹시 비전 불안하거나
아니 그렇지 않아요.
딥러닝 사용은 어떤 부담을
네.
안 해주세요? 그리고 아까 파워포인트에 Thursday라고 써 있었고 다음 과제가
네.
캐서 Thursday라고 써 있었고 혹시
Thursday라고 써 있어요?
잠깐 변경됐나?
아니 미안해요.
왔고
아니요 이거 웬스데이. 네.
수요일까지 영상 1, 2, 3 퀴즈 준비하면 되는 거죠?
다음 주에 수업에서 하나요? 이거 잘못 들어가지고.
다음 주에 내가 디테일한 거를 다시 다음 시간에 알려줄게요.
그러면 일단 이번 주 수요일까지는 수업이
네.
맞습니다.
제가 이해를 잘못했는데
네.
유튜브 링크를 주시는 거는 수업 시간 전에 보고 와서 그 다음날 퀴즈를 보는 거죠.
네. 그리고 그거에 대해서 질문을 하면 돼요.
질문은 그 KUDL에다가
네. 아니면 뭐 수업 시간에 그냥 손 들고 해도 되고.
영상을 보는 거는 그거랑 코스가 두 가지인 거죠.
콜세라.
오늘 영상을
네.
보라고 권해주신 거는 코세라
콜세라 엔드링 머신러닝 그거요?
예 그거랑
그거는 그냥
권장 사항 정도고
네네네.
유튜브는 필수 사항.
그렇죠. 그래서 여기 마지막 슬라이드에 네 이게 Thursday가 아니라 이게 참 웬스데이인데 우리가 월수니까 내가 좀 잘못 썼는데요.
이번 주
네, 그러니까 이번 주 수요일까지 두 개를 보고 그 다음엔 이제 퀴즈를
그건 이번 주만 한 게 아니라 계속
그렇죠. 뭐 하여튼 그러니까 이번 주는 그러니까 저거 어떻게 보면 뭐 이틀 만에 두 개여서 좀 많은 편이긴 한데 아까 얘기했던 것처럼 이제 한 학기 일주일에 한 1.5개 정도로
다음 주는 아예 두 번 다 쉬는 거
그거 내가 다시 알려줄게요.
아실 수도 있는 거.
네, 아실 수도 있어요.
그럼 따로 휴방
휴강이면은 내가 그러니까 수요일까지 내가 그걸 정해서 알려줄게요.
내일 모레.
네.
네, 안녕하세요.
네, 잘 지냈어요?
네,
네.
궁금한 게 있는데 그 머신러닝 모델을 하나 데이터 사이언스로 분류하고 있는 게 있는데 이게 저희가 라벨을 단순히 애큐레시를 많이 높이고 싶은 게 아니라 좀 모델에 대해서 해석력을 좀 많이 기르고 싶어서
네.
모델이 연속된 데이터인데 시간순으로 그 라벨이 다 있는 게 아니고 데이터가 모든 아이디에 대해서 있는 게 아니라 뭐 1주차는 3만 명만 있으면 8주차는 10만 명이고 그렇거든요. 그래서 결국은 10만 명에 대한 프리딕션을 진행해야 돼서
네.
그 10만 명에 대해서 처음에 클러스터링을 하고 그 클러스터링 패턴을 통해서 1주차, 2주차, 3주차, 4주차에 나타나는 클러스터 패턴을 통해서 또다시 클러스터링을 해서 그 클러스터별로 프리딕션을 진행하려고 하거든요. 근데 처음에 클러스터링을 할 때
네.
저희가 데이터 분포가 되게 이상하게 돼 있어서 엄청 좁은 간격의 데이터가 많고 넓은 간격의 데이터가 스파스하게 돼 있는데 저희가 그걸 임의로 데이터의 라벨을 보고 미닝을 하려고 했거든요. 그러니까 데이터의 분포가
네.
그 비닝을 하는 게
이퀄
인포메이션
사이즈.
어떻게 보면 읽는 거고 저희의 많은 선입견이 주관이 들어가 있는데 도메인 지식이 있을지라도 그런 비닝을 하는 게 올바른 클러스터링 하기 전에 비닝을 하는 게 올바른 판단이지. 왜냐면 클러스터링은 언슈퍼바이즈니까 그
네.
라벨의 변화 비율을 보고는 클러스터를 못 찾을 텐데 저희가
네.
처음에 라벨의 비율을 보고 클러스터링을 인터넷에 찾아도 나오지도 않고
일단은 뭔가 클러스터링을 전처리 작업으로서 뭔가 사용을 하겠다는
네.
거, 그리고 그 클러스터마다 뭔가 그 프리딕션 모델을 클러스터별로 뭔가 만들겠다라는. 근데 사실 클러스터링이 이게 좀 정답이 없는 거라 이게 사실 뭐 어떻게 해도 이게 뭐 맞다 틀리다 좀
네.
그게 좀 잘 없기는 해서 지금 이야기한 걸 내가 정확하게 다 이해는 못했지만 뭐 해볼 만한 어프로치죠. 그러니까 결론 네.
주관을 가지고 클러스터가 이미 어느 정도 도메인 지식에 맞게 클러스터링이 될 수 있도록
네. 네.
가이드를 해주는
네. 오케이. 네. 여기 뭐 학기 같은 개념이요? 예. 시기가? 시간이?
네 시간 개념이에요. 쭉 이어지는 패턴.
그러니까 뭐 같은 시간, 같은 어떤 인터벌을 가지는 시간
네.
내, 할 수 있을 것 같아요. 그다음에 그게 이제 데이터 뭐 밸런스 같은 게 좀 문제라 그러면
네.
그거를 막 리샘플링하는 테크닉들이라든가 이런, 네, 그러니까 그게 한쪽은 데이터가 뭐 한 빈에는 데이터가 뭐 100만 개 있고 또 옆에 빈에는 뭐 데이터가 한 100개밖에 없다. 그럼 10,000배 차이가 난다.
네.
그러면 이거를 이게 뭐 이게 일반적으로 그 클러스터링을 하든 아니면 뭐 그 클래시피케이션 할 때도 우리가 뭐 강아지 고양이를 나눠야 되는데 강아지 사진은 100만 장, 고양이 사진은
네.
뭐 10,000장밖에 없다 이러면 여기서도 벌써 임밸런스
네.
프로블럼이 발생이 돼서 이거를 이제 해결하는 뭐 이런저런 논문들이 좀 많이 있거든요. 그래서 그런 것들을 한번 찾아봐도 좋을 것 같고 일단은 할 수 있는 뭐 쉬운 방법 중에는 이제 데이터 개수를 좀 더 적은 애들을 더 늘리거나 그러니까 똑같은 애들을 그냥 복사를 해서 네 그런 식으로 해서 이제 데이터 개수 측면에서 이제 밸런스를 좀 약간은 억지로 맞추는
디시전 트리를 사용해서
네.
엔트로피를 낮추는 친구들의 위치를 기준으로 비닝을 하는 건 어떤가요?
엔트로피를 낮추.
그러니까 DT를 이용해서
네.
그 데이터가 한 10만 명 있는데
네.
DT가 가장 엔트로피를 낮춘 어떤 구간들을 기준으로 비닝을 해주는 건 어떤가요? 어차피 나중에 그 피처는 그 피처 그대로 들어가죠.
네. 근데 그렇게 되면은 뭔가 디시전 트리도 어떤 그 파이널 그러니까 레이블에 의해서 이게 학습이 될 거잖아요.
네.
그러니까 그 레이블 자체가 우리가 최종적으로 클래시피케이션 하고자 하는 그 레이블과 동일한 거라면
네.
그러면 사실 어떻게 보면은 디시전 트리에서 이제 데이터를 어느 정도는 좀 정리 정도는 해서 좀 나눠두는 거죠.
네.
그 다음에 그 내에서 뭔가 클래시피케이션을 하겠다.
네.
근데 좀 그러니까 그런 식으로 하이라키컬하게 데이터를 그 스트래티피케이션, 그러니까 데이터를 이렇게 쪼개서 뭔가 하는 식의 어프로치가 그러니까 왜냐면 데이터 이렇게 뭐 그 특성이나 이렇게 그게 굉장히 상이할 수가 있기 때문에 지금 뭔가 그런 류의 어프로치들을 생각을
네,
하지
네,
않을까 싶은데 그런 게 일반적으로 좀 이렇게 자연스럽게 사람이면 좀 드는 생각인데
네.
실제로 그런 류의 방법들이 좀 잘 동작을 생각한 것만큼 하지 못하는 경우가 많아요. 왜냐하면 그렇게 쪼개버리면 그 쪼갰을 때는 그 문제가 쉬워지도록 이렇게 쪼개는 거잖아요.
네.
근데 그 문제가 쉬워지는, 그러니까 그 약간은 쪼갰을 때, 그 쪼갤 때도 이제 오류가 발생할 수 있거든요.
네.
그러니까 클러스터링을 해서 어떤 기준을 만들어서 어떤 그 클러스터링이라는 어떤 존재하는 그런 이제 우리가 만들어 놓은 클러스터링을 기준으로 해갖고 뭔가 이렇게 그 기존 어떤 테스트 데이터나 이런 것들을 이제 어떤 클러스터로 실제로 클래시피케이션을 하는 게 먼저 그러니까 첫 번째 단계로서 일어나잖아요.
네.
그러니까 거기서 뭔가 좀 잘 못하게 되면 뭔가 얘가 좀 영영 복구 불가능, 회생 불가능이 되는 경우들이 좀 있고, 그 다음에 또 이게 여러 이렇게 데이터들을 쪼개서 뭔가 모델을 각각 다 따로 만드는 경우는 이게 기본적으로는 보통 이제 데이터가 이제 뭐 많으면 뭐 괜찮은데 일반적으로는 이렇게 쪼개고 나면 그 쪼개졌을 때 그 데이터 개수들이 이렇게 적어지잖아요. 뭐 3개로 쪼갰다 그러면 뭐 그냥 균등하게만 쪼개도 뭐 3분의 1로 적어지는 거니까.
네.
그렇기 때문에 그 각각의 경우에 대한 모델을 그 3분의 1만의 데이터로 만들었을 때의 뭔가 그 제너럴라이제이션 성능 혹은 테스트 데이터에 대한 성능이 그렇게까지 좀 좋지 않을 가능성이 좀 높아요.
근데 저희 목적에서 성능이 1순위가 그러니까 성능과 해석력이
인터프리터빌리티.
더블 딱 똑같이 밸런스가 돼 있다면 해볼 만한 트라이였습니다.
네.
이게 하면서도 약간 스스로한테 너무 선험적
네.
가정을 많이 취하는 것 같아서
네.
마음이 불편해서.
그렇죠. 그러니까 진짜 어떤 데이터에 존재하는 어떤 그 특성을 우리가 뽑아낸 건지, 아니면 우리의 그냥 어떤 선입견 혹은 주관 같은 거를 직접, 그러니까 약간은 좀 억지로 주입을 한 건지, 약간 그게 지금 이슈인 거죠.
네.
충분히 이해하는 이슈이고요. 보통은 뭔가 해석을 위해서, 그러니까 뭐 해석을 위주로 하는, 그러니까 해석을 좀 더 잘해보고자 하는 어프로치들이 좀 뉴럴넷이나 이런 데서도 있는데, 그리고 뉴럴넷이 뭐 기본적으로 뭐 이렇게 만들어 놓으면, 혹은 학습이 다 끝나고 나면 이걸 얘가 도대체 뭐 하여튼 해석이 좀 안 되는,
네,
그게
네.
좀 굉장히 좀 악명이 높기 때문에. 근데 이제 많은 경우 이렇게 좀 어떤 선험적인 뭔가 이런 거를 하기보다는 뉴럴넷은 그냥 그것대로 그냥 엔드투엔드로 그냥 다 학습을 하고, 여기서 뭔가 어떤 룰을 후처리적인 작업이나 이런 측면으로 좀 기존 어떤 학습이 다 끝난, 그러니까 전체 데이터에 대해서 학습이 다 끝난 거기 뉴럴넷의 어떤 비헤이비어를 이제 나중에 좀 조사를 해서 그런 어떤 인터프리테이션을 끄집어내고자 하는 그런 식의 조금은 어프로치가 조금 더 일반적이긴 해요. 근데 사실 정답은 없어요, 사실.
뉴럴넷으로
다 일단
클래시피케이션을
해놓고,
하고
예.
뉴럴 네트워크의 피처를 조사해 보면서
네, 그거가 어떻게
인터프리테이션을 오히려.
그걸 하는 거죠. 네,
그럼 2개 다 해보고
네.
비교해 보면 되겠네요.
그렇죠. 네.
결국은 다 해보자. 그리고 혹시 전 그냥 그 다시 2, 3일엔 혼자 공부했었는데 VA나 그런 거 할 때 잠깐 첨가도 괜찮아요?
네, 괜찮아요. 아니면은 그 VA 같은 경우 수업 들었으니까 그죠?
네.
그 내가 그 올려놓은 그 뭐 short course on 뭐 이미지 제너레이션 뭐 트랜슬레이션 이런 게 유튜브에 있거든요.
네.
거기에 내가 그냥
그
약간
이미지 제너레이션
네,
말이죠.
이미지.
어텐션 모델이나 그런 거 이제 교수님 강의 보면서 다시 들었거든요.
네. 그리고 뭐 그게 한 두세 달 됐나? 한 그 정도 전에 올린 게 있는데, 거기에서 내가 VA를 거의 그 어떤 수식적인 거 없이 그냥 설명을 해놓은 게 있거든요.
수식도 약간 이해하고 싶어서.
수식이요? 그래요. 네. 근데 내가 아마 수식을 많이 커버를 할지는 잘 모르겠어요. 네. 왜냐하면 그게 뭐 그 캐리어 다이버전스랑 그 베리에이셔널 어프록시메이션에서 뭐 그런 어떤 바운더리 이렇게 좀 그런 바운더리 올려주고 그런 류의 것들이, 그런 VA를 쓰는 여러 딥러닝 논문들에서 그거 자체가 이렇게 굉장히 좀 그거에 대해서 이렇게 깊은 이해가 요구되지는 좀 않는 것 같더라고요. 그러니까 프랙티컬한 선에서의 어떤 특징을 좀 이해하는 게 좀 그 정도에서 좀 다양하게 이제 그런 효과를 노리고 좀 활용을 하는 편이지. 그래서 뭐 나도 그냥 그 수식적으로 뭐 하려면 뭐 이해를 하는데, 좀 증명이나 뭐 이런 건 다 하는데 뭔가 좀 약간 아직까지 나도 뭐 내공이나 인사이트가 부족해서 그런지 내가 좀 마음으로 이렇게 좀 체득을 한 것 같지가 않아요.
마음으로
내가.
시기 전혀 저한테 와닿는 느낌이 안 들어서.
그러니까 뭐 따라는 가겠는데 이게 뭐 그러니까 직관적으로 착 나한테 이렇게 체득이 된 것 같은 느낌은 나도 사실 안 들어서, 사실 그거를 내가 또 나도 그렇게 안 된 상태에서 강의 중에 내가 그걸 그렇게 할지도 잘 모르겠긴 하고. 그래서 더 확실한 건 요번에는 그 강의는 스킵할 거예요. CS3일에는 그 강의가 좀 안 좋은 것 같아서 그렇게까지.
그리고 혹시 낼 수도 있는데 저 이거 따로 다 들으면서 혼자 렉처노트처럼 한글로 그 교수님 강의하신 거랑 여기 과제랑 렉처노트랑 그 다 합쳐서 제가 정리놓은 혹시 필요하시면
네. 보내줄래요 그러면?
위에 제가 찍어놓은 거.
그 뭐 종이로 있어요?
네, 손으로 하고
아니 손으로 하고 있다고요?
다 했어요. 끝까지 레인포스먼트 라인까지.
아래요? 그렇군요.
필요한 애들 그 자료로 혹시 필요한 모든 강의 다 있고요.
야, 장난 아니네요. 가만있어 보자. 그러면 이걸 나야 뭐 굉장히 도움이 많이 될 것 같고 괜찮으면 이거를 저기 스캔을 좀 해서 보내줄 수 있나요?
네.
아니면 내가 스캐너가 있는데 뭐 하루 이틀 빌려줄 수 있으면
네,
내가
네, 네,
해서
괜찮아요.
넣어줘도 돼요.
제가 그럼 수요일 날이
내가
시간까지
받을게. 내가 받을게.
네, 그래요. 뭐, 훌륭하네요. 네.
아 그러면 혹시
뭐 또 있어요?
아니면 그 네, 지울 거. 그 워드 투백 부분은 이사에는 어사이먼트 따라가면서 정리해 놓은 게 있어요.
아, 진짜요?
네.
오, 그래요.
그럼 나중에
이 사행 관련해서 워드 투백은 나도 그 지난 학기 대학원 수업 때 대학원 수업을 그 이사인으로 하면서 이사 그렇죠. 네. 그 워드 투백을 글로브랑 뭐 이런 거 그 거기서 이제 미분하고 나오잖아요.
네네.
그래서 그런 것들도 어느 정도 좀 유도를 뭐 나름대로는 해놓은 게 있는데 뭐 그것도 혹시 뭐 나중에 기회되면 참고해 줄 거예요. 네, 그리고 그것도 한번 뭐 나중에 공유해 줄 수 있으면 좋고요. 네, 하여튼 고마워요. 네.